Hello CS112, today I'll be going over a quick solution to Lab 3, which had to do with branching with functions. First, I'm going to quickly describe what you were supposed to do in this lab. Next, I will go over a quick solution, and then I will tell you 3 different ways to test your code when coding with definitions. Excuse me. So for this lab, you had to determine if a customer would be happy based on the ratio of pepperoni they got. What I mean by this is if they got at least 75% of their pizza covered with pepperoni, they are happy. If it's less than 50%, they're sad. But if it's anywhere in between, they're neutral about it. So the way that I would go about solving this is first completely understand the question and what I need to do. Once I completely understand the question and what I need to do, I will code a code skeleton. And then finally, I will actually code it. So I'm going to quickly go through those steps. They're very easy, and I'll tell you what each of them. So to fully understand what each of these parameters does and how I can use them to find the ratio between them is, well, it actually told us what we needed to do. We needed to calculate the surface area and then find the ratio between pepperoni surface area to actual pizza surface area. So to fully understand these 3 parameters, I like to draw things out on a paper. So the first parameter, pizza radius, is going to be obviously the radius of a pizza, something like this. And what we were supposed to use to find the surface area is pi times this radius squared. Now the second parameter we were given was the radius of a single pepperoni, so something like this. Now something that you have to keep in mind is if you use pi r squared, which you are supposed to on this, you're just calculating this surface area right here. You got the surface area for a single pepperoni. Now we could assume that all the pepperonis are the same size, and thankfully our third parameter was the total number of pepperonis. So all we needed to do was calculate this surface area and then multiply it by the number of pepperonis. So that surface area has 2 steps to it. And obviously, once I actually calculate the 2 surface areas, I simply need to find the ratio and then follow these steps to return if the customer is happy, sad, or neutral. So now I'm going to code my code skeleton. First, I'm just going to define a variable called pi because I don't want to have to type pi 5 times. And it was 3.14159, I believe they told us to use. Now, what is a code skeleton? A code skeleton is essentially coming up with a design and structure for your code of what you need to do using comments before you actually just go through and start coding. Makes it a lot easier and is actually faster and more efficient, in my opinion, when you're going through when it gets more complex. The first thing I want to do is calculate, if I can type, surface area of pizza. The next thing I want to do is calculate the surface area. Calculate the surface area of a single pepperoni. I want to make sure that even in my comments, I want to document that this is a 2-step problem here. So remember, first I said to calculate the surface area of a single pepperoni, and then you would calculate the surface area total pepperoni. After that, you want to find ratio of pepperoni to pizza. And then lastly, we want to follow the guides up here, which say, I'm going to start with if greater than or equal to, I think it was greater than or equal to, I actually don't have the specs in front of me, 75%, then you're going to be happy. So then happy. Next one was if elif less than 50%, then sad. And as a default, else, you can be neutral about it. Now, it is good to think about the control flow of these 3 statements. The way I have set it up, and this was actually the order they told you it on the sheet, it's easiest for you to code. Because if you have the neutral above on either of these 2 lines, you need to have a compound if statement. You see how these are just if greater than or equal to 75, do something. Elif less than 50%, do something. For the neutral, you would have to say if for elif it is greater than or equal to 50 and less than 75, like a whole compound thing. So that's why I sort of threw it last. All I have to type is else, return this, because you are guaranteed proper inputs and just easiest to code that way. So I'm going to go through and actually code. Now, we were given on the assignment sheets, and I'm sure some of you remember from math a long time ago that the surface area is simply pi r squared. So I'm going to create a variable called pizza SA equals pi times the the radius of the pizza, which is our pizza squared. I'm going to do the same exact thing for a single pepperoni. I'm going to make sure that, excuse me, my variable names will remind myself that that's only for a single pepperoni and not the total one. And I'm going to do the same exact thing. Say pi times our pep squared this time, because we're using the radius of a pepperoni. And lastly, as I've said before, the actual surface area of the pep is going to equal the single pepperoni times the total number of pepperoni. So now I can say single pep SA times num pep. And that will yield the total surface area of the pepperoni. Now to find the ratio of the pizza pepperoni, all we need to do is, all we need to do here is divide the surface area of the pepperoni by the surface area of the pizza. So I'm going to create a variable called ratio and set that equal to the pep SA divided by the pizza SA. Now this will yield a nice decimal point for us. So instead of seeing numbers like 64 and 82, we will see 0.64 and 0.82. You could convert it to by multiplying it by 100 to get these nice clean numbers to say like, okay, if it's greater than 80 or if it's like stuff like that. But I'm just going to leave it as a nice clean decimal. So again, I'm just going to straight up follow my code skeleton, nice and easy, all planned out. I'm going to say if ratio is greater than or equal to 0.75, so 0.75, I'm going to return the string happy customer. Next thing is, again, I'm just going to essentially copy my code skeleton, which is pseudocode, saying elif it's less than 0.5, which is 50%. I'm going to return a sad customer. Lastly, if it's neutral, I don't have to type that compound statement. I can just say else return neutral customer. And just like that, we have completed this assignment. I will go through now and show you 3 ways to test. The first way I'm going to show is the way that you print the actual return values out. The next is going to be using the Python interactive mode in your terminal. And the third, I'm going to show you guys how to use Python Visualizer. Python Visualizer is going to be your best friend in this course, and I strongly suggest you use it, especially if you're new and you're learning how to debug code. So again, the first one I'm doing is I'm going to print out the return value of this function by calling it down here. A couple things to keep in mind. If you just had this portion out here like this won't actually display anything in your terminal. There is a return value associated with this, but because we're not printing it, the return value is only being kept by the computer. And we aren't really assigning it to anything, so it will probably be lost pretty soon. I'm actually not so sure how Python handles this type of stuff. But by printing it out, we're actually going to display the return value. It's important that you guys learn the difference between printing and what a return value is. I strongly suggest you go over that. I'm sure you guys have learned about that in class. Next thing to keep in mind is that I'm calling this print statements outside of the definition. So by outside, it is on the same indentation as it. Everything inside would be inside the definition. So if all of these statements were inside, so if these statements look something like this instead, when I ran this code, nothing would happen because this function is never being called. And lastly, I'm calling this after I define this print statement, or after I define this function here. If I were to call it before, so if I had this line up here, I'll just show you actually what would happen. So for instance, if I go up here and I call it one line before, I'm going to hit save and I'm going to run the code. So Python exec.py, it will give me invalid syntax. Well, that is that is not what I was expecting, but that's just silly me. I need to say elif ratio is less than 0.5. It's not what I was trying to do, but it's always fun to go through this. I'm going to hit Python on that, and yes, here we go. It's going to say pizza coverage is not defined. It's going to start yelling at me for line 6, saying it's not defined. That is because when a Python interpreter is going through here, it goes line by line. It's going to start at line 1 and actually go through every single line. Once it hits line 6, it's going to say, okay, it wants us to display something. What does it want us to display? Keep pizza coverage with these lines. It's going to look for a function called pizza coverage, but it's never seen it before in its life. So what can it possibly do? That is why you need to call it. That is why you need to call it after you've actually done the definition. So here we go. I'm going to hit S for save. I'm going to run it again, and boom, I got the expected outputs. Now, the second way that a couple labs actually showed you how to do this is using the Python interactive mode. The way you do this is you type Python in your terminal -I and name of your Python file. You hit enter, and I'm still actually let me get rid of it. Let me get rid of these actually real quick, uh, just so nothing will be printed. I'm going to type exit to get back out of the Python environments, and I'm going to type it again. I'm going to hit the up arrow key and hit enter. And sorry about that, I forgot to hit save. Let's do this one more time, and there we go. Now, as you can see, I just see 3 carets here. Now I can actually straight up call this function. And the way I'm going to do that is by looking at these again. So I will type in pizza coverage. I don't have to print anything out now because it will simply display it for me. So pizza coverage, if I can type, pizza coverage 5, 1, 10. Hit enter, and it's add customer, giving the expected output. I'm actually just going to copy and paste these because I type today. So again, if I type that, give me neutral customer, and as you can see, it's returning a string. It also shows that the type of value it's returning, and I continue here, happy customer. So it's the same thing. I personally don't like using the interactive mode that much. I feel like you can have a lot more test cases here, stuff like that. But now I'm going to show you guys how to use Python Visualizer, which I like more than both of these, especially when I was starting out. So I'm just going to copy and paste my code. Python Visualizer isn't anything you have to download. It's literally just a quick Google search Python Visualizer, and make sure you click on the Python tutor one, which should be the first one. I'm going to take you to this website, and you can start writing code here, but the main moneymaker is in the live programming mode. So click on live programming mode. And what this enables you to do is essentially code in live time. The visualizer will be constantly displaying your code over here in a box. I'm just going to show you what I mean. So it's going to be constantly displaying your code here as you go. So you don't have to go anywhere else to edit. You can edit it live time. So for instance, if I was debugging my code and I said if ratio is, let's just have a logic error here, say 0.5. Uh-oh, my output's wrong. You see how it automatically updated because I have these print statements here, like I described to you before, the location and stuff. Going to automatically update. So if I were to change it back, I don't have to execute anything in the terminal. I don't have to do anything else. Move it back. Oh, I got the correct output. You can literally code as you update. Another very, very fun thing is that you can actually step through your code. So if you go to the first thing here, again, the first line is red here. As I described before, if I called it on line 5, then it will yell at me that it's not defined, so that you can actually see what Python's reading. So it's going to first point to 6, and it's not even going to enter here. It's going to, because it hasn't been called yet, so there's no reason for it to read this function yet. So the next line it's going to go to, it first is going to shoot down here, so you can see the next arrow. It's going to skip all of this, and it's going to start storing the variables here. It will actually keep your variables live and updated. You can see I define a new variable here. You can step through your entire code. It's going to tell you every single calculation I've made. So I have to find pi, the surface area, by using these functions with pi r squared. It gives me 78 points. That's you're going to get the single pepperoni, total pepperoni, and then the ratio you get. And it's going to do this with every single call. And once it gets the return value sat customer, you hit next, it's printed to the screen as it does here. You can skip to the last, go previous, couple steps. This is like going to be your best tool for debugging your code at this early stage of programming. Obviously, once you get to more robust programs or working with file I/O, this might not be as helpful, although there still is a way to use it by breaking up your code into smaller fragments to test in here.